Alright, today we're going to work on two sections. They're both to do with factoring. And then next day we're going to do the same two sections, but we're going to do the more difficult questions. So I know last year I stressed factoring, and I told you that if you were going to take Pre-Calculus 11, and I assume you are taking Pre-Calculus 11 because you're watching this video, I told you you had to be able to factor, because if you can't factor, Pre-Calculus 11 is a nightmare. So here's your review. If you do not understand this, watch the video again. If you still don't understand, ask a friend and watch it with a friend. If you still don't understand it, come and see me. Get a tutor. Join Kumon, whatever you have to do, but you need to understand factoring. There's 4 types of factoring that you did last year, and I expect you to know all of them. The first one is removing a GCF, and you're always going to try to do this one first. If you're ever trying to factor, the first thing you should do is try to remove a GCF, greatest common factor, right? So we have a polynomial here. It's a trinomial because there's 3 terms. The terms are separated by the minus signs and the plus signs. And what we're going to do is we're going to remove a greatest common factor. We're going to look for the biggest thing that we can take out of these 3 terms. What's the biggest thing you can divide them all by? So if you look at the numbers, we have 12, 20, and 16. And the greatest common factor of 12, 20, and 16 is 4. You should be able to get it that fast, or very close to it. Okay, now we look at the x's. We have 2 x's here, 3 here, and 3 here. What's the most number of x's you can get out of each of the terms? Well, the most you can remove from each of them is x squared, 2 of them, because you can't remove more than 2 here. There's only 2 of them. The easier way that most people think of this is you look for the smallest exponent, so x squared. Now we look at our y's, 3, 3, and 1. The most you can remove is just 1, or the smallest exponent you want, if you want, is a 1. And the z's, 1, 2, and 0. The most you can remove is 0. You can't remove any z's. So this is your greatest common factor right there. Now what you do is you put some brackets and you ask yourself, what would I have had to multiply this by, the 4x squared y, in order to get that first term? Well, you'd have to multiply 4 times 3 to get 12. X squared is great. You don't multiply it by 1, but you don't have to put that. Y you'd need to multiply by y squared, right? Because y to the first times y squared is y cubed. You had the exponents. And you would also need a z. That would give you the first term. How would you get the second term? Well, you'd multiply by negative 5 to get the negative 20. You'd multiply by 1 more x to get the x cubed. X squared times x is x cubed. You'd multiply by y squared. Y times y squared is y cubed. And you would need a z squared to get the z squared as well. The last term, you'd multiply by positive 4. 4 times 4 is 16. You'd multiply by an x to get the x cubed. And that'd be it. You don't need to put any more y's because you just have 1 and you have 1 there. So this is it. Now, this is your answer. You're finished. If you're not sure though, remember the way you could check it, or if you don't understand exactly what we're doing here with factoring, I could go the opposite way. I could do my mountains here. There'd be 3 mountains. And if I was to do these 3 mountains, the answer I would get when I did those mountains is this answer, the original question up there. Okay? But this is the answer when we factor. Then what you do is you look at the part of the brackets and see if you could factor further, but in this case you couldn't. So you're always going to try to do this first. ... Always try to do it first. Okay, so here we go. Binomial difference of squares. This is another type. There's no real first, second, third type, although I will call the removing a GCF the first type because you're always going to do it, right? Okay, so binomial, or difference of squares. These are binomials. There's only 2 terms in each one of them. And when it's a binomial, the first thing you want to do always is to try to take out a greatest common factor. Can you take out a greatest common factor here? 25 and 81. No, the greatest common factor is just 1, so there's nothing you can do. Okay, to factor binomials, it needs to be a difference of squares, so it needs to be a takeaway sign. If it was plus here, you could not factor it by you doing a difference of squares. It has to be a takeaway sign. And what you do is you put your 2 sets of brackets, and you ask yourself, what multiplies by itself? This is the squares part. These are both perfect squares. What multiplies by itself to get 25x squared? Well, you'd multiply 5x times 5x to get 25x squared. What multiplies by itself? This is another perfect square, 81. What multiplies by itself to get 81? 9 and 9. Now all we have to do is figure out our signs. And the signs are plus and minus, or minus and plus. It doesn't matter as long as you have the opposite signs. And remember, the reason you have the opposite signs is because usually when you multiply two binomials together, you get three terms. You get a trinomial. And the reason you only get a binomial here, if you were to do your mountains and valleys here, the reason why you only get a binomial is because one of your mountains is 5x times negative 9, which is negative 45x, and another one is positive 9 times 5x, which is positive 45x, and then those two will cancel. And the only way those two middle ones are going to cancel is if you make them opposite signs. Okay, that's the why of that, but if you don't understand the why, at least remember the what. And the what is, make the opposite signs when you're doing difference of squares. This is your answer. Okay, next one. It's another binomial. If you were to start right away and say it's a binomial, I know how to do this. I ask myself, what do I multiply by itself to get this? You're going to be in big trouble because there is nothing that multiplies by itself to get that. Oh, I guess we can't factor this one. Yes, you can. What do you always try to do first? Take out the greatest common factor. So in this binomial, what's the greatest common factor? Well, you can definitely take a 5 out of both of them. Can't take y's out of both of them because there's no y here. But you can take a z out of both of them. So that's the greatest common factor. What's left? What do you multiply 5z by to get this? You multiply it by 4. 5 times 4 is 20. By y squared. And the z's already taken care of. So that's it. And sometimes people think, oh, well, look, it's 5z and 5z, so it's already taken care of, so this is it. No, because then if you did the mountains, you'd only have one thing. You'd only have the first term. So you must put this second, must have something here in the second term. And what are you going to put? What do you have to multiply 5z by to get 5z? You have to multiply by 1. So that's your second term. Now if you do the mountains, you'd end up with two terms. Right? The first term would be 20 y squared z, and the second mountain would be 5z times negative 1, which is negative 5z. So you must have that negative 1 there. Okay, we are ready now to do our difference of squares. Because this bit inside the brackets is of this type, you can absolutely do your two brackets. What multiplies by itself to get 4y squared? 2y and 2y. What multiplies by itself to get 1? 1 times 1 equals 1. The signs, well, last time we put plus minus. This time let's put minus plus. It really doesn't matter. You can do either way. Are we finished? No, this 5z comes along for the ride. Okay, if once you take out a greatest common factor, it just carries on the whole way. So this is your answer here. Okay, the third type, or another type, is simple trinomials. I've never liked that name. I'm looking for something more interesting than that. If you have one, give it to me, and you'll be immortalized in my math class. But I call them simple or simpler trinomials because they're definitely easier than the ones we're going to do on the next page. And these are the ones where you're solving the little puzzle. You're going to have, again, just like with the binomials, bracket, 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 but you're doing a little puzzle here. And the puzzle is, what are two numbers that multiply to this and either add or subtract to this? Now, how do you know if it's add or subtract? You look at this sign right there, and it's a plus. So you know it has to be two numbers that add to 9. Now, remember, this is a little trick. This is one of the few places in my math class where I do tricks. Okay, so this sign here, it's a trick that it will tell you whether you're adding or subtracting, and yeah, I'll talk about the proper way in a second. Anyway, because the first term's x squared, what do you know has to go here and here? It must be x and x. That way, the first mountain would be x times x, which is equals x squared. Now you're looking for two numbers that multiply to 14 and add to 9. I don't know what it is. Well, actually I do, but let's pretend I don't. Then what you could do is you can make a list of numbers that multiply to 14. The numbers that multiply to 14 are 1 times 14. I'm going to do this systematically. 1 times 14, 2 times 7, 3 doesn't go into 14, 4 doesn't go into 14, 5 doesn't go into 14, 6 doesn't go into 14, 7 goes into 14, but wait a minute, we already did 7 and 2 and 7, so this is done. This is it. There's only two sets of numbers. Which of those pairs add to 9? Well, it's this one right here. So here's the other part of the trick I gave you last year. Once you found your numbers, put the big number in the first bracket, the smaller number in the second bracket, drag the first sign down of the original trinomial, just drag that down so it's a plus, and the way you get this sign is you have to think, is it positive 7 times positive 2 equals positive 14, or is it positive 7 times negative 2 equals positive 14? It's positive 2, right? The way you're going to get this plus 14 is that final valley. So that final value would have to be positive 7 times positive 2 to get the positive 14. And we're done. Okay, we'll do one more of those right here. Again, it's a trinomial. Oh, what did I forget to do, or I forget to mention in this question? I forgot to mention that we should look for a greatest common factor, and we should do that here as well. But there is no greatest common factor, so we're good to go. We're going to put our brackets. We have x squared, so it's going to be x and x. We're looking for two numbers that multiply to 12 and subtract to 4. Okay, to 4, not to negative 4, to 4. Now, this is my trick, right? I find that a lot of people are horrible with negatives. So I teach it that way, that you can find two numbers that multiply to 12 and subtract to 4. You'll never have to deal with negative numbers. But if you want to do it correctly, mathematically, what you're actually looking for are two numbers that multiply to negative 12 and add to negative 4. It's always adding, and it always includes a sign. But if that's too confusing for you, negative 12, negative 4, then just do my method. Two numbers that multiply to 12, it's always going to be positive, and subtract to 4, always going to be positive. You don't have to deal with negative numbers. Okay, so two numbers multiply 12, subtract to 4. I don't know what they are. Actually, I do, but let's write our list again. 1 times 12 equals 12. 2 times 6 equals 12. 3 times 4 equals 12. 4 times 3 equals 12. Hey, wait a minute, we already have that pair, so we're done. These are our only options. Which ones of those subtract to 4? It's these ones. We put the big number in the first bracket. We put the small number in the second bracket. We drag that sign down into the first bracket. Is it negative 6 times negative 2 equals negative 12, or negative 6 times positive 2 equals negative 12? It's positive 2. That's your answer. One more simple trinomial. So this doesn't look like a simple trinomial, and what's the problem here? The problem is this mess out front. The simple trinomials always start with x squared or m squared or n squared or whatever, and this has a negative 3x squared. So what should we do first here? Well, we need to look for a greatest common factor. And if you look at these three terms, most people can figure out that a greatest common factor is 3. And you could call that your greatest common factor. But if you do that, don't write this down, your first term, the thing that's going to be left, is still negative x squared. And we don't like to have a negative for our first term when we have simple trinomials. So rather than making the greatest common factor 3, let's make it negative 3. In fact, if your first term is negative, I would always take the negative out as part of your greatest common factor. Even if it was something like this, if you had negative x squared plus 2x minus 3, I don't even know if that's going to work. But if I had that, what I would do is I'd factor out a negative and then be left with x squared minus 2x plus 3. Okay, and actually you couldn't factor. I gave a bad question there. All right, so we're factoring out a negative 3. So negative 3 times what equals negative 3x squared? X squared. Negative 3 times what equals positive 9x? Negative 3x. Negative 3 times what equals negative 6? Positive 2. Good. Now we look at this part, this trinomial here, and that's a simple trinomial. That's something we can factor. In order to get x squared, we have to have x and x. We're looking for two numbers that multiply to 2 and add, because of that sign there, add to 3. Multiply to 2. Boy, there's not many things that multiply to 2. There's 1 times 2 and there's 2 times 1, but that's the same thing. We're finished. 1 and 2. Sure hope that works. Do those add to 3? Yes, they do. Big number goes in the first one, small number in the second one, drag down the first sign. A negative times a what equals a positive? A negative times a negative. Are we finished? No. Don't forget to drag down the greatest common factor. It comes along for the ride, right? Greatest common factor always comes along for the ride. That's your answer. 3 factors in that question. All right, finally we get to Bobby Bridge. Bridge is actually known, the real true name for this is factoring trinomials with a leading coefficient other than 1. I figured that was too long of a name and I needed something shorter. So a wonderful student who I taught more than a couple years ago now, dear old Bobby, came up with this name. She said, why don't you call it the bridge method? And it was perfect. And then I thought, bridge? Thank you, Bobby. Bobby Bridge. And the rest is history. It's now sweeping the math world, I'm sure. This type is now called in my classroom Bobby Bridge. So let's try to solve this one as a simple trinomial. What you would try to do is to take out the greatest common factor. but there is no greatest common factor. So you're stuck with this 3 out front. And that's what alerts you to the fact that it must be a Bobby bridge. So what you're going to do to solve this is you're going to build a bridge. There you go, it's the Bobby bridge right there. And what you do is you multiply those two numbers together. So again, you don't have to worry about negatives. 3 times 2 is 6. So you're looking for two numbers that multiply to 6 this time and subtract, we're kind of doing the same thing we did up there, two numbers that multiply to 6 and subtract to m? No, what number's here? 1. So you're looking for two numbers that multiply to 6 and subtract to 1. Or if you want to be very mathematical about it, be accurate, you're looking for two numbers that multiply to -6, because 3 times -2 is -6, and add to -1. But let's go with my method. Two numbers that multiply to 6 and subtract to 1. Okay, 6. That could be 1 and 6, or it could be 2 and 3, or it could be 3 and 2, but we already did that. That's it. There's only two sets. Which of those ones subtract to 1? Those ones. Okay, don't write down your brackets yet. You're not doing that. What you're going to do now is you're going to decompose the middle term. And when something decomposes, what does it do? It breaks down, and that's what we're going to do. We're going to break down this middle term. So what we do is we rewrite the first term, 3m squared. But we got to break this middle term down using these terms here. So -1m, and we have to use these two numbers. Are we going to add them both together? No. +2 and +3 is +5, and we have -1. Should we subtract them both? -2 and -3 is -5. That didn't work. We need one positive and one negative. Which one should be negative? Well, we have more negatives here. We ended up with -1, so it must be -3m, because there are m's here, and +2m's. You see what we did? We took those two numbers and we just decomposed this, and we still have our -2. So if you're not clear where these came from, this -1 has been decomposed into those two numbers. -3m plus 2m, if you do that in your head, -3m plus 2m equals -1m, and that's exactly what this is here. So all we've done is taken this middle term and split it into two terms. Now what was the point of that? Well, the next step in Bobby Bridge is to pair them up. And sometimes, incidentally, in questions, they'll give you a question and say to factor, and it'll just be like a question like this. They won't start back here. They'll start with this, the original question. If there's 4 terms and you're asked to factor, try doing this. Try pairing them up. So that's what we do. We pair them up, the first two, the second two, and then we try to take out the greatest common factor of each. So what's the greatest common factor of these first two terms? 3m squared and -3m. The greatest common factor is 3m. What do you multiply 3m by to get 3m squared? M. What do you multiply 3m by to get -3m? -1. Okay, I see a plus sign, so I put a plus. What's the greatest common factor of these two? 2. What do you multiply 2 by to get 2m? M. What do you multiply 2 by to get -2? -1. I know I did it right. How come? Because I got the same thing in both of these brackets. If you get that, you know you've probably done it right. Okay, what you do now is you take those highlighted bits, you take that out as a greatest common factor, like another greatest common factor. So the greatest common factor is m minus 1, or if you want, just write out the part that repeats. And what do you have to multiply m minus 1 by to get 3m m minus 1? You have to multiply it by 3m. What do you have to multiply m minus 1 by to get 2 times m minus 1? You have to multiply it by 2. That's your final answer. Okay, basically what people do in this last step is they take the one that repeats and write it down, and then they put the other bits together, 3m plus 2, and they put it in the second bracket, and you're finished. Alright, we'll do one more of those because Bobby Bridge is quite tricky, and then we'll be finished. We try to take out a greatest common factor to make it a simple trinomial, but we can't, so we have to build a bridge. So we're multiplying 10 times 9, and we get 90. 90? Oh gosh. 1 times 90 is 90, 2 times 45 is 90, 3 times 30 is 90, 4 doesn't go into 90, 5 times 18 is 90, 6 times 15 is 90, 7, no, 8, no, 9 times 10 is 90, and then 10 times 9, whoop, we got them all. Okay, so we're looking for two numbers that multiply to 90 and subtract to 9. Which ones subtract to 9? I believe it is these ones, subtract to 9. So we're going to rewrite the first term, 10m squared. Now we have to decompose this -9m. So how are we going to do that with these two numbers? Again, you want to have more negatives, so it's going to be -15m, and then you're going to have to add the 6m. -15 plus 6 is -9. It worked. And rewrite the last term. Pair them up. First two, second two. Greatest common factor of the first two is 5m. 5m times what is 10m squared? 2m. 5m times what is negative 15m? Negative 3. There's a plus sign, so I write plus. Greatest common factor here is 3. 3 times what is 6m? 2m. 3 times what is negative 9? Negative 3. We got the same thing in both brackets. That's great. I can write that down as one factor, and then I put these two together, 5m plus 3, and we're finished. Okay, please learn this. It will help you in this course, and next year too.